So thanks everybody for joining us for this May edition of AskTOM Office Hours with a focus on PL SQL. And this month, what I'm going to do is start off with a kind of a fast review of associative arrays, how they work at Oracle and in PL SQL, and why you might like to use them, and some of the newest features in 12c and 18c. So my name is Stephen Feuerstein. I'm the Oracle Developer Advocate for PL SQL. With me is Chris Saxon, Oracle Developer Advocate for SQL. Those lines are somewhat arbitrarily drawn, certainly for Chris. He covers a lot more than SQL, including pretty much anything to do with Oracle Database, and he's on the AskTOM answer team along with Connor McDonald and Maria Colgan. Please do follow us on Twitter. Write down our Twitter handles, contact us by email, check out our blogs and our videos, and so on and so forth. Okay, so I'm going to spend a few minutes talking about associative arrays, then we'll open it up for broader conversation in chat. So associative arrays are the oldest type of collection in PL SQL. Interestingly, back in Oracle 7, they were the first type of collection, and back then they were called PL SQL tables. Then in Oracle 8, we added nested tables into the arrays, though I wasn't with Oracle at that point, but I was with it in spirit. And then PL SQL tables were renamed to index by tables because of the index by syntax that you'll soon see if you haven't seen it already. And then in Oracle 9i Release 2, we added string indexed arrays on top of the integer indexed arrays, and we renamed our type of collection to be associative arrays. Of course, the name doesn't matter that much. What matters is what you can do with them. And the reason I really like associative arrays is that they're so flexible and easy to use. First of all, you can index by integer or string. You cannot index by string with nested tables or varrays. You can use negative index values, which can sometimes come in handy for your algorithms. You can take elements that are in your positive array range and just kind of move them temporarily to your negative space and do work in the positive side, move them back. They are naturally sparse. In other words, you don't have to have every value defined between the lowest and the highest index value. You don't have to initialize and extend as you do with nested tables and varrays. So the kind of the overhead of programming with associative arrays are lower than the other two types of collections. But prior to 12c and 18c, there were some advantages to nested tables and varrays, especially nested tables. For example, you could use the table operator and select from a nested table. But as of 12c, you can do that as well. You can use associative arrays within a SQL context in a number of ways. And then as of 18c, we've implemented qualified expressions, or really constructors, for associative arrays and for records. Okay, so enough PowerPoint. We'll come back to PowerPoint when we're going through the questions. Let's take a look at some code. And my favorite way of exploring code these days is using Live SQL. So livesql.oracle.com is a website you can access any time of the day or night to both write SQL and PL SQL, play around with the latest features of these languages, because Live SQL always offers the latest version of the database. We are now running on 18c. If you don't have access to it elsewhere, you can get it here. And what we've also done is build a library of scripts that you can access to learn about our technology. So I'm going to search for associative, and we get all these different scripts, and we're going to look at a number of these today. So let's kind of go through them quickly, give you a sense of what associative arrays can do, and then again, off to questions and answers. So first of all, a quick example of associative arrays. So what you see here is the definition of an index by collection, which means it's an associative array. Whenever you see index by, it's an associative array. I'm indexing by integer. I've got a happy family variable based on this list of names type. And here you see the kind of flexibility you get with associative arrays. I can pretty much pick whatever index value I want between a range of values, about 4.3 billion to choose from. And I can use negatives and positives. They can be sparse, as I mentioned before. They can be sparse. This just uses values that are not sequentially defined by any means. I can then use methods to find out information about the array, how many elements are in it, what's the first or lowest defined index value, what's the highest. And I can iterate through them. This is the classic iteration for a sparse collection. I don't want to go from 1 to the count with a for loop because I might hit gaps. If there's any possibility of a gap, what you want to do is start with the first, and then while your index value is not null, do whatever you're going to do, go to the next one or the prior if you're going backwards, and then stop when the index value is null. And when I run this code, I see my values. And notice it goes from the first, lowest, to the highest. So that's a very quick example of an associative array indexed by integer. Let's go back to my search of all the different associative array related stuff. Now I'm just going to jump around a bit because it's more fun that way. So in 12.1, one of the big advances that we made with PL SQL is that you can now bind user-defined types like arrays, collections, associative arrays, and records within dynamic SQL. So here's an example of binding a Boolean and binding collections. So here's my own collection type defined in a PL SQL package. And I can now, where's my binding? I can bind in that array or record in dynamic SQL, but also I can now select from that array. So prior to 12c, the only time you could select from table operator of a collection was if it was a nested table or a varray. So now that's no longer a restriction. With integer index collections, it's got to be integer indexed. You can also select from that collection as if it were a relational table, and you can join a collection, therefore, to a table data set. You can apply where clause filters to the contents of your collection, and it can even be collections of records, not just collections of individual scalar values. Cool stuff. Let's take a look at qualified expressions. So what's new in 18c? So one of the really nice advantages of nested tables is that you could call a constructor function and create one of those on the fly. With associative arrays, you weren't able to do that, so you had to do a line-by-line assignment of values in the executable section to populate your associative arrays. No longer the case in 18c. So now, when here's my integer indexed type, and it now creates a qualified expression array function. It looks like a constructor function, but they're called qualified expressions. And I can call that function or that expression. I can pass it the values that I want to put into my collection. And notice I use named notation to tell it which index values, or not, in which case it will use, you must use name notation to provide the index values. This will fail. They don't have to be in order. And what that will do is populate the collection in the declaration section, and then you can work with it. So whether you assign the value in the declaration section or the executable section, the bottom line is it's much more compact, much nicer to work with. And it also works for string index collections. Now here's an example that's really nice. I've got a collection of records indexed by integer. And records also, as of 18c, allow you to have a qualified expression. So I'm going to, on the fly in my declaration section, use my qualified expression for my collection type to populate my array, and each element in my array is a record type, so I call my qualified expression for that one, and I construct my records on the fly. Pretty cool stuff. So this is a great example in 18c of the PL SQL team focusing on making PL SQL easier and easier for us to use on a day-to-day programming basis. Write less code, construct things more compactly, manage your code more effectively. Here's an example using qualified expressions for string indexed arrays. So again, I specify the location of my array, which is a string, and the value that I want to put into it. So it works with integer indexed arrays and string indexed arrays. Nice stuff. I hope you'll agree. And you can even use expressions. Look at this. I can use an expression to say, what is the location of my array that I want to work with? Good stuff. So what the question is about is when I select from table, first of all, I can have a column value, which is a fixed name, hard-coded name of a column, if it's a collection of scalars. And what you'd like to be able to do is get the index value from that array. And look, here's another one, the index value of this array, and use it to join. It's a lovely idea. It's definitely on the list to do by the PL SQL team, but currently you do not have access to the index value from the table operator. You essentially have to construct it yourself in the sense that you can construct your collection so that you have one other element. Let's say it was a collection of records. Then you would add to your record an attribute, which is the index value, and then you would populate that index value. I know it's hokey, but that's the only way you can do it right now. So let's take a quick look at string indexing and how it can help you, from my perspective, among other things, really simplify the code that you write. So this is a very simple package I wrote years ago to keep track of strings. Basically, I needed to keep track of a certain name of a variable as being used in some code that I was generating. So I needed to be able to mark a string as being used and then ask if the string is in use. And my first pass at doing that was to create a list of the strings that were used. So it's an index, it's a list of variable names, and that's defined with a subtype, one of my favorite features of PL SQL as well. To mark it as used, I'm going to pass in that string and add it to the list. So notice what I'm doing is taking the count, the current number of elements in the array starting with 0, adding 1 to it, and then simply adding that string to the list. So the list gets longer and longer and longer. Then I ask, is the string in use? And the way I'm going to find that out is I'm going to iterate from the first to the last and look for a match. So while I haven't found a match and I haven't reached the end of my list, it's found if the value equals the value in my array. Now, this is not a lot of code. It didn't take me forever to write, but it's the sort of thing that you do have to sit down and write, then you have to debug and you have to test, and edge cases are always a pain in the neck. And it's just not necessary, because what I could do, and sorry, in terms of not being necessary, the other thing to realize with this kind of algorithm, is that I'm essentially potentially scanning through the entire collection. And as the collection gets bigger and bigger and bigger, the cost of executing this code, depending on where that string match is found, could actually increase. So this is a great example of an algorithm that is not data neutral. Depending on the state of the data in your application, in your session, the performance of your application can degrade, something you want to avoid. So let's take a look at using a string index collection instead. So same API. Mark a string is being used, is the string in use. But now I'm going to declare my array, the list of used strings, as a table of what? A table of who cares, indexed by variable name. Now, what's going on here? So notice I've declared subtype who cares as a Boolean. And I've got this other constant called does not matter. I'll show you that in just a second. So what I'm saying in my code here, I like to write self-documenting code that tells its own story, is I don't care what the value is. Turns out I only care about the index value. So mark a string is being used. I pass in that variable name. I don't add it to the list, which is what I did here. Instead, I use that string as the index value in my collection. And the value and the element value is who cares? It doesn't matter. It's like an index-oriented table. All you care about is the value in the index. So I mark it as used, and then check this out. Is the string in use? Go to that location. Use the exist method to say, does it exist? Done. So now my collection could have 10 rows. It could have 1,000,000 rows. The cost of checking to see whether or not that string is being used essentially will be the same regardless. And of course, it's much less code to write. I'm using built-in declarative programming instead of writing an algorithm. So I think this is a nice, simple example of how string index collections can really help you.
So we had someone was asking, how can collections help improve performance of a program rather than use global tables? And I think the example you just walked through is one situation where this could help.
Tell us more.
Well, if you were writing this to a temporary table, then you've got to go through the process of writing it to the table and then actually querying it back out. Now that can be fast enough, but with the index array, we know that's going to stay in memory, whereas with the temporary table, can be writing to and from disk it's going to be temporary table space, but we know we're not going to hit that with this collection. But so there isn't like a fixed answer of when collections are going to be better than global temporary tables, unfortunately. That's part of the reason both these things exist. We discussed this last time, I think, as well, a little bit, didn't we, Stephen? But like you say, because you've got constant time lookup here, you know it's always going to be that. And you say, do we want to, is that going to exist potentially faster than whatever the SQL equivalent might be?
Great points. And so let me add, too, in general, that the performance of working with collections in memory, so PL SQL collections, nested tables, varrays, and associative arrays, all consume PGA, process global area memory. And in general, accessing PGA memory is much, much faster than SGA memory or system global area memory that's shared across sessions. So the cost of iterating through collections, in other words, the cost of executing the string in use that involves a loop, it's very fast. And unless you've got a massive number of rows, you're probably not going to see a big difference in performance between, say, this implementation and the string indexed implementation. The main advantage here is the reduction in code and the simplicity of the algorithms. So collection manipulation is super fast. And it's almost always going to beat out a SQL operation because you've got the context switch from PL SQL to SQL, and you've got the overhead of executing SQL that you just simply don't have when you're accessing local or session memory. The trade-offs will be things like how big that collection is. So as the collection grows and consumes more PGA, number one, you have the threat of actually hitting the limit for your session. And number two, the cost of manipulating that collection will go up. And also, if you need to work with some from data and tables, you might want to move it all into a global temporary table so that you can do it all in SQL. However, again, with 12c, you can now use the table operator and actually blend in PGA-based collections as a kind of table in SQL with data in relational tables. So it's a nice way to make them work together. So the first one is a question on multiset. So multiset accept does not appear to scale very well and for larger sets, 100,000 rows and higher. It's much more efficient to use SQL with a select minus select query. Have there been improvements in this area since 12.1? Chris, do you want to speak to any improvements while I bring up some code to look at?
So in terms of, I'm not aware of any specific improvements relating to multiset accept that would make its performance work any better than the traditional set operators. However, it is worth thinking if you've got a query that is slow and you're trying to get more performance out of it, there are various other techniques in 12c that are available. So it may be that actually you need to step back and look at the business question, what you're trying to achieve. If whoever asked that is able to give us a bit more background, we might be able to help in a bit more detail. But when it comes to multiset accept itself, nothing particularly new there.
Yeah, I agree. As far as I know, there haven't been any changes. And so let's just step back a little bit and talk about the multi-set operators. In fact, I can show you my code, but why would I do that? Because I'm pretty sure we've got something in Live SQL for you. So multi-set accept. So one of the features, and I believe it was added in 10G, is the multi-set operator. So the multi-set operator allows you to do set-oriented manipulation of nested tables inside PL SQL. Multi-set, you can also use multi-set in SQL, and it's similar to doing the set operators like union, intersection, and minus. So with multi-set, you have accept, which is minus, but they didn't name it minus. I'm not sure why. You have multi-set intersect, you have multi-set union. And the basic idea is that you can take separate nested tables, and you could perform set level operations on them in PL SQL. One of the other nice things about working with nested tables, this is not directly germane, is member of. So just in case you guys don't know about this one, let's look for member of. When you're working with nested tables, this is an alternative actually to the kind of searching that I just showed you. There's also a feature called member of or not member of that will allow you to very simply and declaratively ask, does this element exist in the collection? Again, only for nested tables. So multi-set operators give you a lot of power within PL SQL to perform set level operations on collections in PGA memory. But if you need to do SQL operations, let's take a look at, here's a comparison of nested table and SQL operations. Unless you need to do, if you're doing lots of complex set-oriented operations, you're almost certainly going to be better off with SQL because it's optimized for those kinds of steps. Okay, cruising along. Question on triggers. What is an instead of trigger? Chris, I'll give this one to you.
Yes, so an instead of trigger is something you place on a view, and what it allows you to do is kind of intercept the insert updates, deletes, and instead of pushing those straight down to the underlying tables, you do something else entirely. For example, you could do something, if you're really crazy, like write the data to a completely other table. And of course, this brings a question about why would you ever want to do this? Why would you want to have this kind of craziness going on? And for the most part, you wouldn't. However, there was one situation in the past which I found it very useful. So we were going through refactoring some of our tables. So we were storing flight information, so what people had booked, which flights they'd purchased, and we'd also stored with that details about the flight, such as its departure time. And quite often what happens, sometime after you booking and actually flying, the schedule will change slightly. So the times of those flights will subtly adapt. And of course, if we've then stored what time you've saved, the time the flight departed at the point in time you purchased the flight, that then no longer matches the actual real time the flight departure flies. And this led to all sorts of complicated workarounds we had to do. And really, the real solution here is just kind of drop the flight information out of the booking tables and just join to the flights. So, sounds simple, but of course, now you've gone for a situation where you're just querying one table and you've got to join to them. This is one of the key tables in our application, so that will, huge ripple effects throughout the application. What we were able to do instead of kind of exposing all that was create a view which mimicked the old table and did the join. And then, so you could query the information back out, but of course, when you try and insert someone makes a new booking, they try and insert it, that's not going to work because there's two different tables there. So this is where we use the instead of insert trigger, it was able to map the fields to the correct underlying table. So it can be a good way to help you kind of refactor your database schema with minimal impact on your application. Ultimately, in this situation, you probably want to actually update your real code to use the real tables and do the join, but it's a nice way to help you isolate schema changes without having to potentially change every line, or inspect, review every line of your code. So
nice, thanks, Chris. So you'll see on the screen here an example of an instead of trigger that I loaded up this morning. This is taken from my Oracle PL SQL programming book written by Daryl Hurley, the code itself. And we won't go through all the details of it. You can check it out on your own time. That's the whole idea behind Live SQL. But the basic idea is I've got to join against multiple tables. That's the main data set that people are using and accessing in the application. And of course, you can't do inserts, updates, deletes directly on this view. Well, which table would it be for? So essentially, the instead of trigger says, well, instead of the normal insert operation, I'm going to divert it to run this code instead. And you can see that he's got a lot of logic here. But essentially, what you can see is that it crosses into different DML operations on the different tables, depending on the state of the data that's being passed in. And here we've got one on update as well. So that's the basic idea behind instead of triggers. You can't apply the DML directly, or one of the reasons for using it is you can't apply DML operations directly on views with multiple tables. And so you can basically steer it in a different direction, and you write all the code needed to execute the appropriate DML. Question on log errors. So why doesn't log errors trap my OR 6502 error? So this person wrote to say that she was building a pipeline table function to get the records and pass them back into the SQL statement. But while doing the insert operation that the pipeline function was being used for, Oracle is throwing it a 6502, and she was confused because she thought the idea behind log errors is that if you get an error in your SQL operation, it will log the error and not raise back an exception to PL SQL and allow you to continue. So why was it still failing? And she wondered, well, maybe it's because it's not actually an error in the DML, but an error in PL SQL. And yes, that is almost certainly the case. So I don't have all the code to show you, and I'll show you an example of log errors in just a moment. But the basic idea, first of all, is that if you ever write to AskTOM or to myself or to Chris and say, I'm getting this error, what's gone wrong? We usually can't figure it out unless you show us a simplified version of your code and shows the actual running of that code, preferably on Live SQL, demonstrating the error. Let's take a look at log errors. And Chris, you just dive in at any point if you anything to add.
Yeah.
And sorry, Sven Veller has also said that there's another view, $PGA stat, which should be helpful with analyzing PGA consumption. Okay, so I'm sorry, Chris, were you about to say something?
No, it's fine. It's okay. You can.
So just a quick review of log errors in case you didn't know about it. So log errors is this really great feature where if you put the log errors clause on the end of your DML statement, this is a part of the SQL engine, not PL SQL. You can also specify the number of times you'll accept an error. Then what will happen is that if a row fails, so sorry, let me step back. Here's an update statement against the entire employees table, and we're giving people a big raise. They deserve it. Unfortunately, we might not be able to give everybody that big a raise depending on how large a salary they were already making and the constraints on the column size. Now, in general, without log errors, DML statements like this are all or nothing. Either every single row is modified successfully or none are. And in this case, for example, we found at least one row that we could not update, so the whole thing failed and nothing was changed. And that's usually the way you want your DML operations to proceed. But suppose you're updating 1 million rows. And if you got 900,000 of them done and you had 100,000 left or 3 left that didn't work, that's fine. You want the rest of them to be saved. You add the log errors clause. You'll previously have created a log error table using the dbms error log package. And then when I run the same code, notice it found that it updated 49 rows out of my 107 in the employees table. And what it did was write information about each of the rows that failed out to my log errors table. So here's my logging errors table. It found 58 rows that failed, and then I can look at information about what happened. So that's the basic idea behind log errors, is that if the row level operation fails, rather than force a rollback of the entire statement, it writes information out to this table, undoubtedly using an autonomous transaction procedure, and allows you to continue. But beware, if you do use log errors, and it should be the exception rather than the rule, you've got to check your table afterwards, your error table afterwards, because the SQL engine and the PL SQL engine will not raise an exception at all. Okay, so that's the basic idea there. And this reader or writer was correct in that, as far as we can tell from the limited information she gave us, if you're getting an ORA 6502 or any number of other PL SQL related errors, when you're running your SQL statement with a pipeline or regular table function inside of it, almost certainly, and you've got log errors, almost certainly the problem is within your function. So the first thing you do is you take that function out of your SQL statement and you run it independently and you test it and you make sure that it works. And then you put it back into SQL and see how it works. Now with a pipeline table function, you can't actually run it outside of a SQL environment. You might, so you'll probably have to still keep it in SQL. But in general, I would say as you're building out your code, test incrementally, make sure that your individual units are working before you put them in a larger and more complex context. Anything to add on that, Chris?
No, I think that's just good general advice. Make small, reusable bits, gradually build things up rather than trying to make, I've seen people make one giant, massive procedure, and as soon as anything goes wrong, you're completely stuck. And it's like, why does it do that? So the smaller you can make your functional units and then build on top of them, the better.
Yeah, that's, as you say, that is a great piece of advice to give generally. I just did a code talk session that's sponsored by OD Tug on unit testing and using UTPL SQL, an open source framework for testing. One of the biggest problems I think we have as backend developers is that we write code that's not easily testable. So if you've got a procedure that's 5,000 lines long that updates 25 tables, that has 6 in parameters and 25 out parameters, just coming up with a list of test cases would be horrendous, thousands of test cases. And you're immediately overwhelmed, and so you don't do much of anything in terms of any kind of proactive testing. So in general, when you're writing your code, break it up into smaller modules, make those modules available for testing. You'll have to put them in the package spec, which you can also use conditional compilation to only expose for testing, hide in production. And by making your code more manageable and testable, it's also going to be much more reliable and easier to fix over time. And we have a comment from Judith on the call. Maybe the problem is that the ORA 6502 is raised by the select part of the statement, while log errors logs the errors for the insert statement. If the select fails, then the insert is probably not attempted at all. So yeah, there are a number of possibilities with that ORA 6502 that could be causing the problem. Again, start with the individual pieces like the pipeline table function or the regular table function. Isolate that if that's working and not causing the error, then step further out and take a look at the overall statement. And here's a question from Rajesh. How about the performance impact if we use log errors for millions of records? Chris, what do you think?
So I mean, there is going to be some overhead to doing this. And the key thing here is always just make sure you test and benchmark and see if it actually meets your requirements. I mean, Are you saying this because you're worried that one day you'll hit millions of rows, or are you actually processing millions of rows right now? But it's also important to kind of think about, okay, this has got an overhead, but what would you have to do instead to avoid that overhead? There are various other approaches, such as you could use bulk collection with save exceptions. That might be an alternative. Or you might have to go through some more extensive code to kind of do all this checking to stop any rows which would be invalid ever trying to insert them into the table. And typically, that is going to be much slower than using the database functionality. For a start, any improvements we make to the SQL processing engine, you're going to get those for free if you use log errors. Whereas if you think of a better algorithm or a better way to process your own code, you've got to go through and rewrite that yourself. So it's always better to use the inbuilt functionality unless you've proved that it's too slow for your user requirements and you can write it faster yourself. That's just kind of as general advice. Try and use the functionality if you can, and only step back if you find that it isn't meeting your needs. But if you've got a specific instance, then make sure you benchmark and test and see it does what you need it to.
Great advice, Chris. Thanks. Yeah, I'd say in general, if you're looking at a situation where you're loading millions of rows, doing an insert select involving millions of rows is one thing. But if you actually think that you're ending up with millions of errors in that process of moving data across or doing a bulk operation, chances are you're not going to want to rely on log errors. Certainly you will see a performance impact. It is literally doing an insert into a table. It's a regular old relational table, even if Oracle will create it for you. And by the way, you can actually modify it as well yourself to add columns and so forth. And I'm pretty sure, though, I have to say I don't know for certain that it is calling an autonomous procedure, a PL SQL procedure. So it's almost certainly doing a context switch, writing an insert into the table and committing within that context. So clearly there's a lot of overhead there. I would suggest that if you decide that log errors is a good fit, in other words, you want to suppress errors at the row level, again, that's a pretty unusual scenario, then if you're not looking at a situation where you're expecting relatively few errors, then you probably don't want to use this approach. You probably want to look at alternatives. And as Chris says, relying on the built-in SQL functionality as much as possible is something to look at, including things like SQL Loader. Okay, cruising right along. Question on FORALL. So I got this in my inbox the other day. With FORALL, it is always suggested to use the limit clause to avoid the memory overflow problem. But if millions of rows of data are transferred from one table to another via direct select, is it possible to have the same memory problem? And if so, is it better to use FORALL with the limit clause? Now, I'd like to make this a little bit of a quiz first. So what do you think of this question? Is it better to use FORALL with the limit clause or the statement? With FORALL, it is always suggested to use the limit clause. What's wrong with those statements? Anybody know?
So to see how quick people can think it or type it, and yeah, we get the timer out.
Oh, nobody wants to type an answer? Oh, we got use the limit clause. Never say always. That's always a good one. But there's something factually wrong with this statement. What is factually wrong with this statement? The limit is on the fetch, not the FORALL. Exactly, Tim. Thank you. So there is no limit clause in the FORALL statement. There's a limit clause in bulk collect, and often we use them together. We bulk collect data into an array or set of arrays, make some changes to it, and then push it back with FORALL. But the limit clause is a part of the bulk collect process, and you should use the limit clause at all times to cut down on the amount of PGA memory that you're allocating for those collections. But if you do have a very large collection, or let's say you might have a collection of 10,000 rows, not that large, but you can't do an update of all 10,000 rows at a time, you might have to fall back on incremental commits with FORALL, which is an interesting thing to do. And I think I might have a script on MySQL. Let's see. Please find something. There it is. So if you're working with FORALL and you have the situation where you're trying to put in, let's say, 10,000, 20,000 rows, and you get an error because you don't have the table space size to support that, or rollback segment size. What you can then do is switch to incremental commit processing. Here's the traditional way, row by row, update. If I hit my counter, I'm going to do 1,000 individual row by row updates, then commit and then reset the counter. This approach works. It's very slow, assuming any number of rows. So you'd want to switch to bulk collect and FORALL. But anyway, you can go through my example of using FORALL with a limit with a pseudo limit clause. So FORALL doesn't have limit per se, but you can limit it by the start and end in the range of rows for your collection. Let's go back to the question though to get some clarity here. So we do suggest that if you're using bulk collect followed by FORALL, that you do use the limit clause. So you're fetching 10 rows or 1,000 rows or 10,000 rows at a time, but not fetching everything in the set of tables to then do the update. And then is it possible to have the same memory problem with SQL? Chris, is that an issue?
So the same memory problem, no, in the sense that if you've got a SQL statement, it's not gonna run out of memory in the same way that bulk collect would. You're not gonna blow out your PGA. However, you can have a different problem in the sense that when one individual SQL statement is processing too much data to fit in memory, it will have to write it to the temporary table space. So it will stage that data and kind of go, right, I'll come back to that at a later point. And of course, at this point, you're then starting to read and write from disk. And as soon as you start having to read and write from disk, the performance of your query is going to drop drastically because disk is still hugely, on orders of magnitude slower than memory. So you don't have the problem in the sense that your whole program's going to crash, but you might have a problem in the sense that it could be potentially a lot slower. Now, exactly when you'll hit this and how it happens entirely depends on your SQL statement and what you're doing. But this is something, I was mentioning before about looking at the execution plan, looking at the tracing it and seeing what it's really doing. This is where you can get into that analysis of what's going on, seeing whether it's using that information or using that temporary data.
Thanks, Chris. So I think the way to sum up on this page on the question about FORALL, first of all, if you can do it in 100% SQL, if you don't need to use collections and FORALL and PGA and bulk collects, that's great. You should do it in straight, pure, lovely SQL, encapsulated inside, say, a PL SQL procedure. So that's always the best. If you do need to use FORALL, you want to avoid row by row processing and you can't do it in straight SQL, or either because there's a requirement that makes it impossible, or maybe you can't figure out how to write it in straight SQL. Some of us are not amazing SQL gurus like Chris and Connor and Kim and Tom and so on and so forth. You can always fall back on writing PL SQL, and you could compensate by using FORALL and bulk collect. We had one other comment from Sven. The question makes sense when we consider the limit clause for bulk collect. It's only useful if we also do a FORALL. Otherwise, we can use a simple for loop, which also does bulk collect. So it is true that as of 10G, a cursive for loop for record in query will automatically bulk collect 100 rows at a time. So you do get the advantage of avoiding row by row fetching with a cursive for loop. That's not always the optimal approach. Even for larger volumes of data, you might get better performance out of doing your own explicit bulk collect with a fetch limit clause, because then you could say, I want to get 1,000 rows at a time or 10,000 rows at a time. But in general, you want to look at using bulk collect versus, say, a cursive for loop if inside that loop you're doing DML operations, inserts, updates, deletes, because then you're getting into row by row DML operations, and those are very, very slow. And did we have one other comment in chat?
Yeah.
So when do we use FORALL? Yeah. Do you want to take that?
Yeah, so I think Stephen's kind of covered it a little bit already, but in general, you should look to do it in a single SQL statement. But there may be situations where between actually querying the data and writing it, you might need to do something complicated. Maybe you need to do some complex calculations on that data before actually writing to your table to the table. And in that case, processing it in PL SQL can be faster than doing it in the SQL engine. So that's one instance. In my experience, I can't think of a situation where I've needed to do that. So probably think carefully about whether it really is faster. A more common example, a more useful example, is when you're processing large volumes of data. So let's say you're processing 100 million rows. That is going to take a little while. It doesn't matter what you do, doesn't matter what knobs you twiddle or what approaches you're going to take. It's going to take some time. And there's nothing more frustrating than have a process that's going to process doing 100 million rows. It gets to the 999 millionth whatever, and then breaks for some reason. Network error, runs out of undo, who knows, and the whole thing falls over. So you've wasted all that time. What using bulk collect and FORALL can allow you to do is break up the processing. So you're staging it and doing it bit by bit. You do have to think very carefully about how you're writing your transactions. So you say, how do we know when we save this that we, don't reprocess it again if the whole thing fails? But there are situations like that where something like this can help. Stephen?
And I just brought up a script on the screen from MySQL about save exceptions. So the other reason to use FORALL versus a single SQL statement is that you can actually trap exceptions on a statement-by-statement basis. So you can keep on processing. This is a level of error suppression above log errors, which is row level. This is statement level. So it'll help you preserve your changes. Okay, and I have one comment here. Coming back to the question on memory usage of associative arrays, you might also take a look at SQL Monitor and Oracle Enterprise Manager, which shows live SQL in execution. It can give you some additional insights.
Yes.
All righty. We're coming up on the end of our hour. We've got one more question. This one's for Chris.
Mm-hmm. Partitioning, yes. Okay, so this is a interesting question, and it's something that people have been struggling for a while. Is how do I've got a non-partition table and I want to convert it to a partitioned one. And traditionally, there hasn't really been a good way to do this because you've essentially got to rebuild the entire table. So you've got your current table, which is non-partitioned, and then you've got to clone it, make a new table, which has the partitioning properties you want. Obviously, that's kind of tricky to do because particularly if you're thinking about partitioning it, the starting table almost certainly is large, has millions or billions of rows in it. So you've got a process of copying from the old to the new. So we had various techniques. The very simple technique to do this was just do a create as select, where you provided the partitioning properties. But in order to do that, in order to do it correctly, you needed to have an outage for your application, which isn't very good for a lot of people. So what we introduced is this DBMS redefinition package, which allows you to change physical properties of a table online. So things like its partitioning options. So it's a relatively convoluted process, and it's best to kind of look it up and rather than me try and explain it here. But essentially you say it manages the process of translating those tables for you. So it's the same principle. You've got your old table, you've got your new table, you're copying data from the old to the new, but this just adds some extra steps in there and allows you to do it in an online way, so you don't need hours of outage to do this. So this is techniques we've had in the past, and like I say, they're all a bit clunky and not too great. So in 12.2, we introduced the ability to partition a table using an alter table statement. So now you can do alter table, modify partition, and specify your new partitioning properties. And so you can change it to hash range, whatever. You can even specify subpartitioning as part of that as well. So this is much simpler, much easier to do. You don't have to faff around with DBMS redefinition or whatever. And it's an online operation, so you can do it online. There are also some questions about the managing the indexes there. So if you've got a bunch of indexes on their existing table, then when they switch over, what do they become? Do they become global indexes or do they become local indexes? Well, you can specify that as part of the alter table as well. So that is much easier to manage. So the other questions. How is the index created on a partition table? Well, you know, just as same way we create a regular index. You do a create index. If you want it to be a local index, then you specify the keyword local. And when it comes to creating a local index only on one partition, this again is something which in it's 12.1 actually, we introduced this. We got local index. You can disable indexes on particular partitions. So you can say, I don't want any indexes on this partition. So disable that feature for you. I think to kind of get more into this local global index, it's a there's a lot of ins and outs to it. There is no one straightforward answer. If there was, there would only be one type of index. Connor's got a great presentation on partitioning, which you can download off the AskTOM site itself. So if you go to the resources tab there and look for his partitioning, he talks a lot about the ins and outs of that. Yeah, we're kind of coming up to the hour, and I think it's, if you want to know more, we're probably better to address that in a separate office hour session.
Great point, Chris. And Chris, in fact, has a SQL Office Hours session. You can come back and hammer him about partitioning. But Connor has put together a really great resource. This is a single page on partitioning. He's got a series of videos. So do check out this page and dive in deep.